Welcome to another episode of Fort Bend Mathematics Tutoring. Take a moment to soothe your nerves. Remember, these is just numbers. They can't hurt nobody.
Ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial lesson is going to be about finding probability, especially when you're dealing with a deck of cards. So let's take a look at this. First of all, I just wanted to highlight a few things about probability, and that is basically it's the part that you want over the total. The part divided by the whole. That's probability, ladies and gentlemen. It's what you want in particular divided by the total amount of outcomes that are possible. That's the probability. The values for probability are always going to be between 0 and 1, and most of the time they're just proper fractions, ladies and gentlemen, all right? So those are the type of values that you're going to be dealing with when you're dealing with probability. And a lot of times you can also convert those into percents and stuff, but before we get into that, let me just show you exactly what I'm talking about specifically with a deck of cards, all right? So when you're dealing with a deck of cards, just note that there are several things you just should know that a lot of people just don't know. You play cards all the time. How do you not know this, right? First of all, a deck of cards has 52 cards in a deck. 52 cards, and these are decks of cards that do not include the jokers, by the way. So a lot of these math problems that have probability, you're not going to be including the jokers, so just discard the jokers. They're not going to be part of the problem, okay? So we're going to start out with 52 cards. There's 4 suits in the deck of cards. You'll have diamonds, hearts, clubs, and spades. Those are the 4 suits. There are 13 cards in every suit, and there are 3 face cards in each suit, the jack, the queen, and the king. They have faces on them. That's why they're called face cards. And then finally, you have 4 aces in the deck. 4 aces. That's it. And a lot of times, ladies and gentlemen, the aces are used for 1, and then blackjack is used for 1 or 11, but you really don't have to worry about that stuff in most of these probability problems, all right, that deal with a deck of cards. But bottom line, you just need to know that there are 4 aces in the deck. An ace is not a face card, and it's not a numerical card, okay? It's just an ace. We'll just leave it at that. Let's get our eyes on a deck of cards, all right? Let's check that out. So no, I'm not about to whip out a deck of cards from the casino, but I will show you this. So here, that first line here, this first row, that's going to be your clubs. The second row is going to be your spades. Third row is your hearts. And the fourth row are the diamonds, all right? So notice that each row contains the ace card. Remember I said that it could be substituted with the number 1. So you have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, the jack, the queen, and the king. Every suit has those same cards involved in it. So 13 cards times 4, you get 52 cards, and that is your standard deck of cards, ladies and gentlemen, just like that. All right, so now let's get to some probability problems. Okay, in problem number 1, this P stands for find the probability of pulling out a red card. That's what it's asking you. It's asking you the probability for pulling out a red card. So to help us out in each problem, at the bottom of our page of the screen here, I've gone ahead and pasted in this deck of cards for reference. So notice, ladies and gentlemen, that we have red cards in the heart suit as well as in the diamond suit. So we know that each suit has 13 cards in it. So that means that for what we want in this, we'll have the following. We'll have 26 cards. In other words, half of 52 is going to give us 26. So 26 of those cards are going to be red. Remember, it's always what you want over the total. So the total amount of cards in the deck of cards is 52. So I end up with 26 over 52. Then you're always responsible for simplifying your result. So as a fraction, this will reduce by 26 to give me 1/2. That's right. 1/2 is the probability. So here we have our result as a fraction, but sometimes they may ask you to write the probability as a percent. Remember, you can write your fraction as a percent by multiplying by 100 over 1. So I can say that I have 1/2 times 100 over 1, and I can simplify before I multiply. So I'm going to reduce both of these by 2. Multiply straight across, I'll end up with 50 over 1, which is simply 50%. And that's it. All right. So here we have our probability written as a percent, and it's also written in fractional notation. Either way, ladies and gentlemen, that's the answer. So the probability of pulling a red card from a deck of cards is 1/2. That's it. 5/10 if you want to write in decimal notation. Let's move on to the next problem. Here we are. Next problem here. What is the probability of pulling out a queen out of a deck of cards? So I'm pulling out one card from the deck of cards, and I want to know the probability of pulling out a queen. Well, here we are. Let's look at that deck of cards again. All right, and your queens are going to be right here. So here's your queens right there in that column, and it looks like I have 1, 2, 3, 4 queens out of that deck of cards, right? So knowing that I have 4 queens, I'm going to say that I have 4 out of the total number of cards in the deck of cards, which is 52, and that 4 over 52 were reduced to 1 over 13. That's right, I had 4 divided by 4 and 52 divided by 4, and that reduced to 1/13, which is my answer. That's it, 1/13. Okay, and that's the probability. That's it. That was problem number 2. It's not bad. Not bad. Let's continue on. I got plenty of examples, all right? So here, problem number 3. What is the probability of obtaining an odd numbered card from a deck of cards? And in this problem, we're not going to include the ace because remember, I said in some card games, the ace counts as a 1 or 11. It all depends. But they'll be specific when it comes to probability. When they want an ace, they'll ask for an ace, okay? Or they'll say a non-numerical card or something like that. But when they say odd number card, it literally needs to be a number in Arabic numeral. All right, so let's look at our deck of cards here. In our deck of cards, the odd numbers are going to be the 3s, the 5s, the 7s, and the 9s. Those are going to be your odd numbers. And notice that for every card that you have, you can really just multiply that by 4 because you end up with 4 of that same number because we have 4 suits. All right, so if I have the 3, the 5, the 7, and the 9, that's 1, 2, 3, 4 numbers that I have that are odd in each suit, and you multiply that times 4. So bottom line, I have 4 odd numbers for every suit, and there are 4 suits in a deck of cards, and I know that the total number of cards is 52. All right, and 4 times 4 is 16 over that 52. And I can simplify this by 4, so 16 divided by 4 is 4, and 52 divided by 4 is 13, and this is going to be my solution. So the probability of pulling out an odd number card from a deck of cards is 4 out of 13. So out of 13 attempts, 4 of those attempts should be odd number cards. All right, so that's the probability, 4/13. Okay, let's move along. That was problem number 3. Here comes problem number 4. In problem number 4, we want to know the probability of pulling out a face card. Remember, your face cards on the deck of cards are jacks, queens, and kings. So let's look at that real quickly right here. So in this deck of cards here, remember it's the jacks, the queens, and the kings that are your face cards. So how many of these are there? There's going to be 1, 2, 3 face cards, all right? So 3 of those cards are going to be face cards times the fact that you have 4 suits. So that's going to be over your total of 52. So you end up with 3 times 4, which is 12, over 52. And this reduces, ladies and gentlemen, by 4 to give me 3/13. And that's the answer. Done and done. So the probability of pulling a face card from a deck of cards is going to be 3/13. Just like that. All right. Good stuff, ladies and gentlemen. That's problem number 4. Problem number 5, here we are. Now in problem number 5 is asking for the probability of pulling a factor of 12. Well, let's look at the factors of 12 real quick, okay? So the factors of 12 that I know of are going to be 1, 2, 3, 4, 6, and 12. These are factors of 12. Well, how many of these factors can we find in the deck of cards? Well, let's see. I know that I have a number 2 in the deck of cards. I'll have a number 3 in the deck of cards. I have the number 4 in the deck of cards. And I also have the number 6 in a deck of cards. The 1 doesn't exist and the 12 doesn't exist. Remember, an ace is just going to be an ace as far as the probability questions are concerned. All right, so let me show this down here in my deck of cards. I'm showing that I'll need a 2. That's a factor of 12. 3 is a factor of 12. 4 is a factor of 12. And 6 is a factor of 12 that we can find in the deck of cards. Remember, each of these choices here will be multiplied by 4 because you have 4 suits with that exact same number in it, okay? So setting up what I want divided by the total. So I have 4 cards that are factors of 12 in each suit, so that's why I'm going to multiply times 4. over the total number of cards in a standard deck of cards, which is 52. Then multiplying straight across, I'll end up with 16 over 52, and this simplifies to give me the following result: 4/13. Remember, 16 and 52 can be reduced by 4, so this is my answer. That's it. Done and done, ladies and gentlemen. That's the probability of getting a factor of 12 out of a deck of cards. There you go. Problem number 5 is done. Let's continue on. Problem number 6. In problem number 6, I have the probability of getting a non-face card. A non-face card. So once again, I want to come up with what I want divided by the total. So here, looking at a deck of cards here, I know that if I want a non-face card, so then that means that I'll be excluding those face cards. All right, I don't want those, but what I do want are all the other numbers. Remember, an ace is a non-face card. It doesn't have a face on that card, so therefore there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cards per suit that are going to be non-face cards. So let me show you how I'm going to set that up. In the numerator, I'll have 10 cards in each suit that are non-face cards times the 4 suits in a deck of cards, all over the total number of cards in a deck, which is 52, and then I'll multiply it and simplify it out. Here, 10 times 4 is 40, so that makes 40 of those cards that are non-face cards out of a 52 card deck, and I can simplify both of these numbers here by 4. All right, so simplifying them by 4, I'll end up with 10/13, and this is the answer. So the probability of getting a non-face card is 10 out of 13. That's problem number 6. Done and done. What I wanted was non-face cards. That's what I got over the total, and I simplified. That's problem number 6. All right. Problem number 7. We want to find the probability of getting an ace or a deuce. Okay. Now, a deuce, ladies and gentlemen, is simply the number 2. So if you ever see the word deuce in a probability problem that deals with a deck of cards, they're simply talking about the number 2. That's it. Which is why they have that song out there by Chris Brown, Deuces. There you go. All right, I can deuce. Okay, you're not following me, but anyway, bottom line is a deuce is the number 2. Moving on, the aces that we have, all right, are located here in this column right here. And then since we're looking for a deuce, aka the number 2, there you go. So if we want a deuce or we want an ace, let's see how many we have of each of those. Bottom line, what I want is the fact that I have 4 aces in a deck of cards plus the fact that I have 4 deuces in a deck of cards. So anytime you see the word or, you'll be adding that information together in the numerator. All right. So as far as what I want, I'm going to add those amounts together. The fact that I have 4 aces in a deck and the fact that I have 4 deuces, aka the number 2, in a deck of cards, all over that total amount, which is 52 still. And so you'll add that together in the numerator to get 8 over 52, and then simplifying the 8 and 52 by 4, we end up with 2/13, and that's the result. Done and done. That's the probability. So keep in mind that when you're dealing with the word or in your probability, you'll be adding those pieces together in order to get your probability, just like that. All right, so that's problem number 7. Let's continue on. All right, in problem number 8, we're looking for the probability of pulling out a heart or the number 4, okay? So let's look at this in our deck of cards here at the bottom. We know that the hearts will include all of these numbers right here, okay? And if I'm looking at the number 4, then I'm looking at these numbers right here, right? Well, notice that this 4 is overlapping, so I only need to count it once, not twice, but once. So let's take a look at this. We're going to start out with what we want. There are going to be 13 hearts, ladies and gentlemen. So that's why I'm counting my 13 there in the numerator thus far. And there are 4 number 4s, but we already counted one of those 4s already. So remember, I said that it was overlapping. When I counted these 13 hearts, I'm already counting that number 4 right there. So now I just need to include the 4 of diamonds, the 4 of spades, and the 4 of clubs, and that's it. So that's just those 3 other cards that I need to include in this problem. So I have 13 plus 3 all over 52. Combining my 13 plus 3 together, I end up with 16 over 52, and then I can simplify that to give me 4/13, and that's my answer. Done and done, ladies and gentlemen. Just like that. So once again, we had the 13 hearts, and then we only had 3 more 4s to include in that solution, because I had already included that 4 of hearts with the other hearts in that group right there. Okay? So that's how we ended up with 13 hearts plus 3 more 4s to add to that numerator. And then we simplified. So the probability of getting a heart or the number 4 out of a deck of cards is 4 out of 13, 4/13. That's it. All right. Next problem. In problem number 9, we have what is the probability of pulling out a red card or the number 5? Well, let's take a look at it here. We know that half of the cards here, ladies and gentlemen, are red, aren't they? Okay, because we have 2 suits that are red, the hearts and the diamonds. So all of these are going to be included, and that's 26 red cards, right? In addition to that, I also want the number 5. So I have the number 5s right here. So remember, in that first grouping, I have those 26 red cards. Well, that included 2 5s, didn't it? So I don't want to count that twice. So I only need to include these 2 5s that are left over from the spades and the clubs. So let's go ahead and set up our numerator here. What we want is 26 red cards plus 2 more 5s, all over our total 52 cards in a deck. Then let's sum it up in the numerator and simplify. 26 plus 2, that gives me 28 over 52, and I can reduce both of these numbers by 4, and that's going to give me 7/13, and that's the answer. Just like that. All right. Once again, the fact that we had the word or in our probability, it meant that we needed to add those 2 things together. So we had to combine the red cards plus the additional 5s that were left over once we took out those red cards. All right, so there you go. That's problem number 9, ladies and gentlemen. Let's keep it moving. Keeping it moving here. Getting you some exercises in today. We have problem number 10. What's the probability of getting a club or an even number? All right, well, let's take a look at that. Well, here in our setup, we know that the clubs are all of these right here. All right, those are our clubs, and we have 13 of those. Then we want the even numbers. Well, even numbers are 2, 4, 6, 8, and 10, just like that. So let's compile all of this together. We know that what we want are clubs, and there's 13 of those, right? Okay, then we want to include the even numbers. We want to make sure that we're not overlapping any of the numbers that we had in our first group, right? So we're going to make sure that we only include what's left over after taking away those clubs out. So we already have the 13 clubs, and then for every even number, we only need to get those 3 that are left over after we took out that club already. All right, so there were 1, 2, 3, 4, 5 columns that had even numbers in it, and it's going to be 5 times 3 to give me 15 cards. All right, so bottom line, ladies and gentlemen, if you just added all these up together, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, those were 15 more even numbers that we could compile in our numerator together. All right, all of that's going to be over the total amount of cards on a deck, which is 52, and now we'll be combining these together. 13 plus 15, that gives us 28 over 52. Then we'll simplify both of these numbers by 4 to get 7/13, and that's the answer. Done. All right, that's it, ladies and gentlemen. That's a nasty red box, but we'll be okay. Let's move on to the next problem. Let's just move on. For number 11, I want to find the probability of picking a card that is greater than 3 and less than 10. That's what I'm looking for. Greater than 3 and less than 10. All right, well, let's look at our deck of cards here. Numbers that are greater than 3 and less than 10 will be the following. It would be 4, 5, 6, 7, 8, and 9. So these columns are going to include values that are greater than 3 and also less than 10. All right. So in putting our probability together, we have 1, 2, 3, 4, 5, 6 numbers that are greater than 3 and less than 10. So in putting my probability together here, I have the 6 numbers that are greater than 3 and less than 10 times the 4 suits that you'll find them in, divided by the total number of cards in a deck of cards, which is 52. Multiplying that together, you have 6 times 4, which gives you 24 out of 52, and you can simplify both 24 and 52 by 4. So reducing these by 4, you'll end up with 6 over 13, and that's your result. 6/13. Done and done. All right, that was problem number 11, ladies and gentlemen. Okay, next problem here. In problem number 12, we're trying to find the probability of pulling out a red king and then pulling out an even numbered card without replacement. All right, so that means I'll be pulling out 2 cards in this probability, not just one like the previous problems. Here, I'm pulling out 2 cards, one behind each other, and I won't be replacing the card that I pull first. Okay, let's see what this looks like. First of all, we're going to start with a red king. Well, looking at our setup here, the only cards that are red kings are these 2 right here, right? So we have a king of hearts and we have a king of diamonds. So that's 2 cards. Then we'll go ahead and say that there is 2 red kings out of 52 cards. Next, we want to be pulling out an even numbered card for that second card that we pull out. All right. So where are our even numbers? Well, we have an even number here at 2, 4, 6, 8, and 10. So there are going to be 1, 2, 3, 4, 5 of these numbers that are even, and there are going to be 4 suits, right? So that means that I'm going to have 5 times 4 all over. Remember, there's no replacement, so how many cards are left over? 51. Remember, we already pulled out a card, and that was one of the original 52 cards. So without replacement means that I didn't put that red king back in, so there are only 51 cards left over. Multiplying in that second numerator, you'll have 2 over 52 times 20 over 51. Okay, so now simplifying before I multiply, I have 2 goes into itself once. It'll go into 52 26 times. 26 can be divided by 2. That'll leave me with 13. And then that means that 2 goes into 20 10 times. So I'll multiply straight across. And 1 times 10 is 10. And 13 times 51 is going to be 663. All right, and that's it. That's the probability, ladies and gentlemen. Done and done. So once again, in setting this up, we had the probability of pulling a red king out for our first card and then an even numbered card without replacement. So find the probability of that first scenario. We had 2 kings out of the 52 cards, and then you'll multiply that when you pull out that second card, and we had 5 even numbers times the 4 suits to give us 20 over the remaining number of cards in the deck, which is 51 cards. So from there, you simplify and multiply straight across. You end up with 10 over 663 as your probability. And that's it, ladies and gentlemen. That was problem number 12. All right, here we have problem number 13. What is the probability of pulling out a black card and then a red jack without replacement? Okay, without replacement. So looking at our deck of cards here, we know that half of the cards are black, right? So that's going to be 26. So we'll say 26 out of 52. Then we'll be multiplying times the red jacks. So our red jacks here are going to be right there. Those are red jacks. So we have 2 cards that are red out of the 51 cards that are left over. Okay. Once we have this set up, I know that 26 goes into itself once, that 26 goes into 52 twice, and then we can reduce the 2's. 2 goes into itself once, 2 goes into itself once, and then you can just simply multiply straight across. So 1 times 1 gives me 1, and then 1 times 51 is 51. So the probability will be 1 out of 51. That's it. Done and done, ladies and gentlemen. That's the probability of pulling out a black card, then pulling out a red jack without replacement. That's problem number 13. Let's look at the next one. Problem number 14. We want to find out the probability of pulling out an odd numbered card, then another odd numbered card, then an even numbered card, and we're going to do all of that without replacement. So for the first card that we pull out, we need an odd numbered card. So let's check that out. The odd numbers in our deck of cards, ladies and gentlemen, are going to be the 3, the 5, the 7, and the 9. And for each one of those numbers, of course, we'll multiply times 4 because there are 4 suits there. So that first card has a probability of 16 out of 52. Okay? Then they're telling me that the next card I pull out is going to be an odd number card. Remember, this is going to be done without replacement. So we already pulled out an odd number card, so there are going to be 15 odd numbers left over. All right? And the total number of cards in the deck are now at 51. The next card, that last card, needs to be an even number. Well, where are our even numbers at? We'll have even numbers here, 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 and also here. So that means that we have even numbers at 2, 4, 6, 8, and 10. Times the 4 suits that you have, that 5 times 4 gives me a total amount of 20 even card numbers. So that'll be 20. And then remember, we already took out 2 cards already. So there are 50 cards left in the deck. From here, I want to simplify like crazy if I can. So what I'm going to do, ladies and gentlemen, is I'm going to start out by saying that 20 and 50 can be reduced by 10. So this is going to be 2, and this is going to be a 5 here. I do know that 5 goes into itself once, and that 5 goes into 15 3 times. I also know that 3 goes into itself once, and 3 goes into 51 17 times. I can also simplify the fact that 2 goes into itself once, and 2 goes into 52 26 times. I can reduce the 16 and the 26 by 2. So 16 divided by 2 is 8, and 26 divided by 2 is 13. From here, I'll multiply straight across, ladies and gentlemen. So I'll end up with 8 in the numerator, all over 13 times 17, which is 221. All right, and that's the answer, ladies and gentlemen. The probability of pulling out 3 cards in succession, the first being an odd number, the second being an odd number, and the third being an even number, is 8 over 221. And that was done without replacement. That was problem number 14, ladies and gentlemen. All right, let me keep that steady for you. There you go. All right, that was problem number 14. Moving on. Problem number 15, ladies and gentlemen. We have find the probability of pulling out a prime number and then a red face card, and we're going to do that with replacement. Okay, so we're looking for prime numbers out of the numbers available in our deck of cards. I know that 2 is a prime number, 3 is a prime number, 5 is a prime number, and 7 is a prime number. Exactly. So that's 1, 2, 3, 4 numbers times 4, remember, because we have 4 suits. So that gives me 16 out of 52. Then I'm going to multiply that times the amount of red face cards. Well, our face cards, remember, are Jack, Queens, and Kings. So it looks like we'll have 6 of those available to us. 6 face cards that are red. So over here, remember this is done without replacement, so we'll have 6 over 52. And that's how we'll initially set it up. Remember, this did not go down to 51 because it was done with replacement, which meant that after I pulled out that first prime number card, I put it back into the deck. All right, I put it back in. I replaced it. So from here, I'm going to simplify. I'm going to have 4 goes into 16 4 times, 4 goes into 52 13 times. I'm going to have 4 goes into itself once, and 4 goes into 52 13 times as well. Then I'm going to multiply straight across. So 1 times 6 is 6, and then 13 times 13 is 169, and this is my answer, ladies and gentlemen. That's it. That's the probability. That was number 15. That does it for finding probability when dealing with a deck of cards, ladies and gentlemen. This was Larry Whittington, Mr. Witt with Fort Bend Tutoring. As always, please rate, comment, and definitely subscribe. Click that subscribe button. And if you're able, ladies and gentlemen, please donate. We really appreciate it. Peace.
We certainly hope you enjoyed today's mathematics presentations. Did you learn anything? Do you need to review your notes? Take a deep breath and congratulate yourself. I am learning mathematicals.